Okay, in this video we are going to talk about the derivative. So this is basically the first video for the derivative. Okay, so we will talk some introduction of the derivative. I will review on the slope of a line, and then I'll give you the definition of the derivative, and we'll do some more examples. Okay, so first of all, let us look at this figure. This is x-axis and the y-axis. This green curve is fx, okay, f of x. You see that? And at this green curve, I consider a point P whose coordinate is x comma y. So if this coordinate is x comma y, so this distance must be x, right? And then that distance must be y. You see that? And little right on the x, that means about delta x distance from x, that I consider another point. So little further right from the point P, I consider another point Q. Suppose that the distance between this x and that point, the distance is delta x. So this whole length will be x plus delta x, right? Because this length is x. You see that? That length is x and this length is delta x. So the whole total length is x plus delta x. Okay? And suppose the height at the point x plus delta x, the height of the function at the point x plus delta x is y plus delta y. So the coordinate of this point Q is x plus delta x, comma, y plus delta y. So what is the slope of the line joining PQ? So we call PQ is a secant line. Why we call secant line? Secant line is a line that intersects a curve at 2 points, okay, or more than 1 point. So this is a secant line, okay. So the slope of the secant line is, it is like, you can think this has like x1, y1, and this has like x2, y2, right? How do I find out the slope of a line? It is y2 minus y1 over x2 minus x1, right? So you do y2 minus y1 over x2 minus x1 equals to, what is y2 minus y1? It is y plus delta y minus y1 is just y, right? Over, it is x plus delta x minus x. You cancel out that y and negative y and positive x and negative x. So what do you get? You got delta y over delta x. You see that? So basically what you can think that a different way too, because this is delta x, right? This length is basically delta y. So this is basically the ratio of rise over run, because when you go from the point P to the point Q, then the rise is delta y and then run is delta x. So you can think that way too. So basically the slope of this secant line is delta y over delta x. The slope of the secant line is delta y over delta x. Let us do something different here. What I want to do is, I want to decrease this length delta x. If I decrease delta x a little bit, so how does it look like? If you decrease that delta x a little bit here, and that point Q will move this point, right? And then your tangent line, your secant line will look like this. You see that? When you decrease the value of delta x. Similarly, if you decrease the delta x right here, let me use different color for that. If you decrease the delta x a little bit more, then that point, that line, the secant line PQ look like that. You see? Similarly, if you move the point delta x somewhere here, then how does that look like? Then that secant line basically look like a tangent line. You see that? The PQ line. So when delta x tends to 0, meaning when you make delta x small, small, and small, then x and x plus delta x will be almost the same point, right? At that time, then the secant line, then the secant PQ becomes a tangent line at P. You see that? This is the point P. The slope of the tangent line at P, in that case, will be m equals to, so it is limit delta x tends to 0, meaning we are taking delta x very small, right? Which is exactly the same slope, because that point is xy and that pink point will be x plus delta x, y plus delta y, right? And the slope will be exactly same. So it will be delta y over delta x. This is the slope of the tangent line. Okay, so in terms of x and f of x, so if you write this as using f of x, so x is the x, right? Y is f of x. You see that? You can write this as x comma f of x. That is x comma y. So this point will look like x plus delta x and then comma f of x plus delta x, right? You can write that way too. This is just another way. So y plus delta y can be written as f, meaning that height is the f, right? F x plus delta. So height at x plus delta x. That's what it means. So you can write exactly the same thing as f of x plus delta x minus fx over delta x, right? How did I get that f of x plus delta x? I can make you another figure to show just that thing. So basically what is happening there is basically look at this. This is the point P, right? So what is the coordinate of that point P? So it is x comma fx, because y is fx, right? This is x. So the name of the curve, the equation of the curve is just y equals to f of x. Now this is delta x, right? So what is the coordinate of this point? It is x plus delta x, right? So what is the height of that function at that point? It is like q, right? X plus delta x comma f of x plus delta x. That is basically, f is basically the height, right? So height at f plus x plus delta x. That's what we are doing. So if you write that way, then it is basically when you move that. So in other words, you can do like this. So this is delta x, right? This will be, how much is that length? This is fx. This height is fx, right? And then this, the total height is f of x plus delta x. So this, how much is that one only? So it is basically f of x plus delta x minus fx, right? And this is delta x. So you can write that way too. So it is exactly the same thing. So how can you find the equation of the tangent line then? Equation of the tangent line can be found as limit delta x tends to 0, change in y over change in x, or delta y over delta x. Or another way of saying the same thing, exactly same thing, is limit delta x tends to 0, f of x plus delta x minus fx over delta x. So this is another way of writing the slope of the tangent line at a point pxy. Okay, so this is basically the slope of the tangent line, slope of the tangent line at px comma y. This is, or you can, oh, I wrote the same thing here, px comma y. So this is basically, this formula give you the slope of the tangent line. You can use either of those two formula, or either delta y over delta x, or limit x delta x tends to 0, x plus delta x minus fx over delta x. If you are worrying about why do we use delta x, why not a simple notation? Delta x is a small number. Just delta or just x doesn't make sense here. It is delta x is one single quantity, because delta x is the length from x to that point. Okay, so delta x is a single quantity. You can write just h instead of writing delta x, you can write h. So in that case, the formula will be limit h tends to 0, right? And then f of x plus h minus fx over h. You can do that too. So it is perfectly fine. Okay, let us define the derivative of a function. So the derivative of a function at a point is basically the slope of the tangent line. Okay, so the derivative of f of x at x comma y is, we denoted by you, sometimes we denote by f prime of x, or we denote by dy over dx. Some people denote like that too, or some people denote like y prime. Okay, these are the all notations we use for the derivative. Okay, so but the formula is, and given by f prime of x equals to limit delta x tends to 0, f of x plus delta x minus fx divided by delta x. So this is the formula of the derivative or the slope basically. So slope of the tangent line at a point P and the slope of and the derivative of a function at that point are the same thing. Okay, so f prime of x equals to limit f of x plus delta x minus fx. So this is plus. Okay, so x plus delta x minus fx over delta x. If you want to find out the derivative at x equals to a number like x equals to c, then we denote by f prime at c. We read like f prime of x or dy over dx or y prime. That little dash is called prime. Okay, so f prime of c equals to limit delta x tends to 0, f of c plus delta x minus f of c over delta x. Basically that x will be replaced by c. So we will see some more examples, but before we do the example, let me tell you something about the slope. Okay, if there is a line, then slope is the slope of that line, meaning that any point, if you pick any point, you will get the same slope. So if you find the slope of this section or that section or that section, you will get the same slope. Okay, if it is a line. But if it is a curve, slope means the slope is different because it is decreasing here. The slope is negative, right? It is not neither increasing nor decreasing at that point. The slope is 0. So it is increasing here. The slope is positive. So how do I find out the slope of a curve? That is basically, to find out the slope of the curve means we find the slope of the tangent line at each point. For example, at this point, we draw a tangent and find the slope of that tangent. At this point, draw a tangent, that's the slope of the tangent. At this point, draw a tangent and find the slope of the tangent. And similarly at all other points, meaning that in case of the curve, slope means slope at a point. Okay, slope at a point. And how do I find out that? To find out slope at a point, what we do is we basically find out the slope slope of the tangent line at each of the point. That's what the slope means for a curve. Okay, so for a curve, slope changes at each point. Okay, all right.